All right, we're dealing with right triangle problems, square problems. Each one of these problems that I assigned for you last night, they all have a right triangle involved in it. So every one you can create a right triangle. Now, how artistic you get with your picture, that's up to you. You can tap into your creative mind a little bit and draw a little bit bigger picture if you want. To me, it's going to be all stick figures and a basic right triangle. But if you want to fluff up a tree or something like that, you can fluff up a tree. That's entirely up to you. We will go through a few problems here today, and the rest of the time will be a worksheet given to you that's going to start reviewing some of the ideas that we have talked about. We take a look at problem number 18. The cable car problem. Wendy Upmore. Good old Wendy is waiting for the cable car in the 600 block of the Powell Street in San Francisco. Since the street seems to be so steep, she decides to find what angle it makes with the horizontal. She was bored. Math nerds, they're going to sit there and try to find a math problem somehow. Wendy is a math nerd. Okay, so she wants to find the angle it makes with the horizontal. On the wall of the house, she measures the horizontal, pulls out her trusty little ruler, measures, like I said, she's a math nerd, pulls out the measuring stick, horizontal and vertical distance. You have 5 and 33 degrees, or centimeters, respectively. What angle does Powell Street make with the horizontal? So here we have Powell Street. And they give you a triangle. They give you a triangle there. You have 33 degrees, or 33 centimeters. And we have 5 centimeters here. That is the triangle that they're dealing with here. And they want to know what angle you make with Powell Street, which is this angle here. So hopefully, and as I walk around, I see your papers, what I see is your trigonometric Indian sitting on your paper, which should happen. So you can have an easy reference to what we need to deal with. SOHCAHTOA should be sitting on top of every paper so you can sit there and easily refer to it. What we want to find is we want to find this angle. And as we've talked about these before, you got to ask yourself, so which trig ratio relates the angle that we want to find to the two sides that we know? The angle we want to find to the two sides we want to know. Here's our angle. Here's our two sides. We have a right angle there. You assume that you have vertical and horizontal lines. You're going to have a right angle there. So what trig ratio relates these two together? Jenna? The tangent. So the tangent of theta is equal to, and write out the equation here. Write out an equation because you want to solve an equation. Because when we solve equations, we have techniques of being able to solve equations. If we have to get rid of multiplication, we can divide. If we have to get rid of division, we can multiply. Okay? If we have to get rid of a tangent or a trig function, we'll talk about that here in a second. How do you get rid of that? Equals what ratio, Jenna? 5 over 33. Opposite over adjacent. Write yourself an equation. Because once again, if you have an equation there are methods to be able to solve equations. What we want to solve for is we want to solve for theta. We want to get theta by itself. Well, what's attached to the theta? Well, tangent is attached to theta. Tangent's attached to it. So we have to figure out a way. How do we get rid of tangent? And that's what we've been talking about. How do we solve this equation? If we want to solve this, Lucas, how do we get rid of tangent? Inverse tangent. So we could take the inverse tangent of both sides. Just like if I'm trying to get rid of a square, I take the square root. If I'm trying to get rid of a square root, we square. Okay, to get rid of a trig function, we take the inverse trig function. Now, in your calculator, I'm going to take the inverse tangent because these will cancel out, leaving us with just theta of 5 over 33. And that's what you can click-clack in your calculator. You don't have to find the decimal first. You can just do your inverse tangent. So we have second and tangent. And go 5 divided by 33. Make sure you close your parenthesis out. Okay, you don't have to find the decimal first and then rewrite the decimal down. You don't need to do that. Okay, you just need to do this. Show me that you're taking the inverse tangent of both sides and then find your answer. 8.61 degrees or 8.62 degrees. So that's my angle, 8.62 degrees. While she waited, Wendy went up the top of the block, counting 101 paces. She is tall and figures each pace is 1 meter long. How long or how many meters did she go vertically? So now what she is saying is this street is 101 meters because it's 101 paces, and 101 paces is 101 meters because she is tall. She wants to know how far vertically she went. So we've just expanded this triangle. Now, if we take a look, we have a line here that we call a transversal. That's the street. We have these two lines extend. We have parallel lines. These two parallel lines are cut by a transversal. These two angles are called corresponding angles. This 8.62 degrees is going to be, no matter where I have it horizontal, it's going to be 8.62 degrees. So this angle up there will also be 8.62 degrees. She wants to know, or we want to know, I'm going to give it Y because it's going up and down, how far vertically she has traveled. If this is 101 meters, 101 paces because it's 101 meters because she is tall. 101 meters, 101 paces, she is tall. This angle is 8.62 degrees. We want to find what Y is. Once again, anytime you go vertically and horizontally here, you form a right triangle. So, one must ask themselves once again, so, which trig ratio relates at 8.62 degrees to Y in 101? Write yourself a trig ratio. That's an equation. Okay, write yourself a trig ratio, that's an equation. The sine of the angle, the cosine of the angle, the tangent of the angle is equal to 1 over 1. So write yourself out an entire equation, because solving equations is what we do mathematically to make life easy, because we have rules to solve equations. Which trig ratio relates the Y to the 101? Write yourself a trig ratio. Check with somebody around you. Then solve that equation. Solve the equation. Bless you. Max, what trig ratio did you write? Sine of 8.62 is equal to what, Max? Y over 101. Because we are going, here's my angle. This is the opposite leg. It's the opposite leg. And since we're across from the right angle, that is the hypotenuse. So we have opposite of our hypotenuse. So we have the sine of 8.62 is equal to y over 101. Okay, we want to solve for y. Or we're dividing by y. We want to solve for y, or by 101. So what do we have to do to both sides to solve this equation? Allison, first. Multiply both sides by 101 because that gets rid of my division by 101. So we have 101 sine of 8.62. Clickety-clack, clickety-clack. Sarah, what do you get for a solution? 15 point what? And make sure we get units there. Meters, which would be paces because she is tall. Make sure you get your units in. Last one, if Powell Street had been level instead of slanted, how many paces would Wendy have to walk to 600 blocks? So we're trying to find this distance up here now. What is this distance, x? Once again, what trig ratio relates to 8.62 degrees, x to the 101? Write yourself a trig ratio. If you wanted to, you could use your good old buddy Pythagoras too, but we're going to look at trig ratios. Both would work. Since you're a part of the Pythagorean Brotherhood, you're allowed to do that. Honorary member, I'm sorry. Not a member of, an honorary member of. Only if you lived in the BC time would you be a member of the Pythagorean Brotherhood. Then check your answer with somebody around you. Amber, what trig ratio did you use? Cosine. 8.62 is equal to what over what? And whatever variable you use, that's fine. I use x. X over 101. We're going to do what to both sides? 101 multiplied by 101, 101. And what do you get for that distance? 99.86 meters, or 99.86 paces, because she is tall. Surprising? I don't know if you're surprised by that, but they ask you that question. Every one of your problems, draw a picture, draw a picture, draw a picture. There should be a right triangle that goes with every problem. When you draw a picture, you don't have to visualize what's going on. You can calm yourself down as you're drawing the picture and start understanding what's going on with the picture. And then you can start realizing the trig ratios that you have to utilize. Once again, the technique of being able to add another dynamic to how to solve equations. Okay, we can handle it if we multiply, divide, add, and subtract. Okay, we should be able to handle that by now. But now we have the new one here, which is, how do you get rid of a trig function? Well, how you get rid of a trig function is you take the inverse of that trig function. Any other questions you have on any of the other problems? Once again, I'm not going to go through every problem in class. Okay, it's practice for you. If you have questions, you need to ask. If you don't have questions, we'll move forward. Okay, now, what we're going to have for the next couple days, today and also Monday. Monday, we'll have an in-class assignment that goes with this. But we'll have a worksheet that look very similar to this. These worksheets, what you see here on these worksheets are going to be very similar to what you're going to see on the review sheet and the quiz next week. It's going to look like the exact same thing, but just, once again, changing the names and numbers to protect the innocent. I have one proud papa moment with respect to mathematics. My kids, I had 3 kids came through here. They didn't quite embellish and enjoy the aspects of mathematics as much as I did. But my daughter, who went to college, and she had to be in a physics class in college, the guy gave him an extra credit opportunity to research a scientist or a mathematician and do a little report about it. She pulled out the good old buddy Pythagoras. And she said, Dad, did you know that there was like a cult that dealt with they're called the Pythagoreans? Did you know that? I said, yeah, we talked about it in class. Showed how much she paid attention to when I talked about the Pythagorean brotherhood. So, but she didn't have to report on it and talked about all the ideas of the Pythagoreans. Okay, there was a pretty decent sized cult there that everything was very hush hush and secret. All right, what you have here, you have trig ratios, finding trig values. Okay, then you have finding the angle, which means you're going to have to find the inverse trig values. If we look at problem number 13 or problem number 14, we'll look at 13. Problem number 13, real quick. Problem 13. You need to find the indicated trig value, the cosecant of theta. is equal to 3.12. I want to find the sine of theta. The first thing we need to calculate, given this information, is we need to calculate the angle theta. We need to calculate the angle theta. I have the cosecant of theta is equal to 3.12. I can take the inverse cosecant of both sides to solve for theta. Problem is, though, we don't have that button once again on our calculator. We don't have the inverse cosecant button on our calculator. So we have to go back to how do we solve for theta when I have a reciprocal function? Anybody remember the first thing we did? Anybody remember the first thing we did? Yeah. 1 over sine of theta. We rewrote it as a reciprocal function. What do we do next? What do we do to both sides next? Mitchell? Flip them. Flip both sides. So we have sine of theta is equal to 1 over 3.12. Now to solve for theta, we have the sine of theta there. How do we get rid of the sine to both sides? What do we do? Take inverse sine. So we have theta is equal to inverse sine of 1 divided by 3.12. Now we can click the clack to our calculator. Unless you have the memorization. Caroline Pearson, what do you get? 18.7. 18.7? Good for that? Okay, now what we want to find is we want to find the sine of this 18.7. So you can have the answer there, or if you want to, you can just do the sine of your answer that you just found. You can find the sine of your answer, then you don't have to click and clack so much. Once again, it's a tool that you want to utilize with your calculator. We have the inverse sine of 1 divided by 3.12. I get to 18.7. I can take the sine of the second and my negative sign. That pulls that answer down. Pulls the answer down for you to get your value. Once again, KYC, know your calculator. The things it does for you. Okay? It is a very nice calculator because it will do so many different things for you. All right, the rest of the time is going to be yours. I have some solutions up here. I will also post solutions. Feel free to ask questions of each other. That is fine.